So we know that when we name an ionic compound, it is always the cation name followed by the anion name. So when we look at an ionic compound, all we have to do is figure out what the cation name is and what the anion name is. So we've been focusing only on ionic compounds, but when it comes to the quiz, you're going to have to distinguish between ionic compounds, binary molecular compounds, and acids. So when you're naming, the first step is always determining what type of compound it is. It is an ionic compound if there's a metal in it. That's our criteria. It's a binary molecular if there are two nonmetals, and we'll go over the criteria for an acid later. So if it is ionic, which in this case it is because that's all we've gone over, name the cation and then the anion. So to name the cation, it is always the metal. After you name the metal, the next thing you want to do is determine whether that metal has a variable charge or not. And if it does, figure out what that charge is based on what the anion charge is. Remember that the charge is expressed as a Roman numeral. So we want to remember that we can use the periodic table to identify whether an element is a metal or not. And that will let us know not only the name of the cation, but whether the compound is ionic. So let's look at these examples. Write the name of the following compounds. So I'm going to look at A, capital N lowercase a, capital B lowercase r. So I look on my periodic table and capital N lowercase a, sodium is a metal. So I know it's going to be an ionic compound. So I'm going to name the metal, which is sodium, and then I'm going to name the anion. This is a monoatomic anion, and its name is based on the elemental name and ends in "ide." So here is the element, capital B lowercase r, that's bromine, so the ion is going to be bromide. So sodium bromide. The next thing I want to ask is, does sodium have a variable charge? So I look at the periodic table. Any metal in the first column has a charge that is fixed. It never ever changes. So it doesn't have a variable charge, so I'm done. That's the name. All right, let's look at this next compound, capital C lowercase r, capital C lowercase l, and then a subscript 3. So look at my periodic table, and here is capital C lowercase r. This is chromium, and it's on the left-hand side of the periodic table, so it's a metal. So I know this is going to be an ionic compound. So I'm going to start out by naming the metal. I know that's the beginning to naming the cation. And then I'm going to name the anion. So the anion is monoatomic. There's only one symbol here. One capital letter and lowercase, so one symbol. And that anion is based on the element chlorine. So the name of that anion is going to be chloride. All right, so the next thing I need to do is ask myself, does chromium have a variable charge? And if it does, I've got to figure out what that charge is. So I look at chromium, and yes, I can see by its position on the periodic table it has a variable charge. How do I know it has a variable charge? Well, it's not in the first column, it's not in the second column, and it's not aluminum, zinc, or silver. Those are the only metals that have a fixed charge. All other metals have a variable charge. So I've got to figure out what its charge is and put its charge in as Roman numerals in these parentheses. So the way to do that is look at the charge of the anions, the total charge of the anions, because whatever the charge is of the cation, it's got to cancel out that of the anions. So I look at the periodic table, and I see where chloride is. It's in the halogen family, and all of the monoatomic anions from this family always have a charge of -1. So if I have 3 of them, that means I have an overall charge of -3 due to those 3 chlorides. Excuse me. So if my charge of the anion is -3, the charge of my cation has to be +3. So the name of this compound is chromium 3 chloride, where the 3 represents the charge of the chromium. Now, it happens to also represent the subscript here, but that's not always the case. We have to be clear that this Roman numeral refers to the charge of the cation. So let's look at this example. Name FeO. All right, so I look on the periodic table. I notice that capital F, lowercase e, is a metal. Its name is iron, so I know it's an ionic compound. So the cation name is going to be based on the elemental name iron, and then the anion name, this is a monoatomic ion. It's based on the atom oxygen, so this anion name is oxide. All right, so does iron have a variable charge? Well, I look at the periodic table. It's not in the first column, it's not in the second column, and it's not aluminum, zinc, or silver. So therefore, it has a variable charge. So I've got to figure out what the charge is and put that charge in parentheses as a Roman numeral. So I've got to know what the charge of my anion is. And when I look at my periodic table, I see that oxygen is 2 columns away from the noble gases, and so it's going to have a charge of -2. Oxygen, sulfur, and selenide always have a charge of -2 when they are ions. So my total charge due to the anions is -2. That means the charge due to my iron has to be +2. So the name of my cation is iron 2 because that's its charge. So this is the name of this compound, iron 2 oxide. Notice that there is not a 2 anywhere in the formula. This Roman numeral 2 refers to the charge of the cation. And we always figure out the charge of the cation based on what the charge of the anions are, because the cation has to cancel out the charge of the anion.